Okay, so we are doing the problems that you don't know how to do. I need no talking. This is serious. There are some people in here that really need to do well. So let's be quiet and respectful of those people. And here we go. What? You need to be more specific. What problem is it? So mini review number 8. Find a polynomial whose roots are 3 and 2i. Well, first of all, you got to remember that imaginary roots, i's, come in pairs. So if 2i is a root, so is negative 2i. They always come with a conjugate. So if 4 plus I is a root, 4 minus I is a root. They never come alone. They're always together. Now, I need to build the polynomial. So this root would come from this factor. Agreed? That root would come from, if I made a factor, it would come from that. That would say x equals 2i. And x plus 2i would say x equals negative 2i. Think about solving the equation, setting the factors equal to 0, working backwards. Okay? Now I FOIL. All 3 of them have to be multiplied, but I always suggest you start with the i's because things are going to cancel out. So it's a regular FOIL. We all know how to FOIL. And those will cancel. What is I squared? Negative 1. So all that first original FOILing works out to be x squared plus 4. And then I still have to multiply the other one, so I'll FOIL again. And there's my polynomial. So basically, bottom line, build the factors and multiply. Anything else on the front of this page, we'll just do that first. So the mini review, the top page of the packet, anything there. 2C. Okay, now, whether it's 2A, 2B, or 2C, it doesn't matter. To find a y-intercept, you're going to let x be 0. Listen to me, it doesn't matter what the equation is. If you want a y-intercept, x is going to be 0. So if I am doing problem 2C, I'm going to put 0 in, and it looks like I'm going to get negative 18. That's it. Yeah. Well, every equation ever in the whole wide world, you want the y-intercept, you let x be 0. All right, anything else on this page? It kind of got run off at the bottom.
Can we go over like 16, but it's like kind of pasted on the side?
Yeah, we'll just make up anything. So x plus 4 squared, x minus 1 cubed, and we'll just say x plus 2. And we want to know the degree. What does that mean? What does that mean? Biggest power of x. So if I FOIL this all out, which I'm not going to do, but if I did FOIL it all out, like this one came out to be x cubed, so this one would be, there's 2 x's right there, there's 3 more right here, and there's 1 right there, so x to the 6th. The degree of the polynomial is 6.
So we just, the answer is 6.
It says, what is the degree? 6. Yep. 4. Find the vertex. Yeah. So to find the vertex, which is a point, we can find x using our little formula, which is, Michael?
Negative B over 2A.
negative b over 2a. And look at our equation, so that would be 6 over 6. So my x coordinate of my vertex is 1. And then how do I get the y? Plug in 1. So 3 minus 6 plus 1, negative 2. And there's your vertex. Now, 17 says find the vertex, but that equation is already written in vertex form. So number 17, the vertex would be negative 2, negative 9, negative 2, negative 9.
Can you go back to number 4 and just, I got confused after we found what the
Plug it in. Do the arithmetic. Plugging in 1 for the x's. So 17, that vertex you don't do this with. That vertex, you just look at it. It's shifted 2 left and 9 down. So negative 2, negative 9 for that one.
Can you do 15?
15, find the inverse. Oh, how do we find an inverse? We have some steps we follow. What steps do we follow? Where am I? Boys and girls, seriously? We don't remember how to find an inverse?
Don't you go to the other side somehow?
We switch our variables
Oh, yeah.
and then solve for y. So 6x equals 2y minus 1. I'll add 1 and divide. And that is my inverse. So you switch the variables and solve for y. That's basically it. All right. Cross off 14. 14 I should have crossed off. Back in the old days when I actually saw my students on a regular basis, we got through chapter 4 in the first semester. I don't do that anymore. All right, anything else on the front side here before we turn it over? Yep, which one? 3. How do I evaluate a function? What do I do? No. Sydney,
What?
if I said to you, find f of 1, what would you do?
Put 1.
Okay, so it says find f of x minus 1, so what am I gonna do?
Plug in f of x minus 1.
So 3 x minus 1 squared plus 9 x minus 1 minus 2. When you evaluate a function, you plug in whatever they tell you. Doesn't matter what it is. It can be letters, it can be numbers, it can be shapes, it can be anything. You plug in whatever they tell you. So now I'm gonna have to do some arithmetic. So this is a FOIL. That is a FOIL right there. I'm gonna FOIL that. So I FOIL that out. Do not square everything. That's not how it works. It's x minus 1 times x minus 1. And then I have to distribute. Now, some of the arithmetic might take you longer, but I don't want to use up all of our review time on arithmetic. So you can go back and go through the arithmetic on your own. Collecting like terms. I think I added that up right. That would be the answer if I added correctly. Okay, and that's the answer. Don't do anything to that. Like, don't try to use the quadratic formula or something. That is the answer. I need a formula for. Which formula am I gonna use on number 12? PERT, yep, that's PERT. And I start with 123 of them, and they're growing into 567 of them. Now, this growth constant is given as a percentage. We never put percentages into a formula, so we'll have to put 0.112. If it's given as a decimal, that's fine, decimals are fine, but anything that's given as a percent has to be changed. All right, step one, divide. This is definitely a calculator problem. That's right, it has a little star next to it. Then what? ln divide. So ln 567 over 123 is going to equal 0.112. And then we'll divide by 0.112. So ln 567 divided by 123 divided by 0.112. So I got about 13.644 days. How long will it take? It'll take that many days. Okay. All right, let's turn it over and look at the back of that page. Uh, 16 and 18 are the same, so I'm not gonna do both of those, but I can do one of those. Everything else looks like it's different. So, what do you wanna do on this side? 16? Anybody remember what I start with? Where I start, I have to build an equation from this picture. I start with the x-intercepts. So I'm gonna have x plus 3, x plus 1, and x minus 2. Those are my factors because those are my x-intercepts. Right? Now, look at the picture. I know this guy right here has to be squared. And this guy right here has to be squared because the curve is tangent or bounces at that point, right? It just comes down, just hits and goes back. That means the factor is squared. I also know that this curve has to contain the point 110. So it has to go up high enough to get up to that point. That height is controlled by a leading coefficient, a vertical dilation number, a multiplier, a height adjuster. And to figure out what that leading coefficient is, I will just plug in the point that needs to work. So 10 equals A or N or whatever letter you're using. 1 plus 3, 1 plus 1 squared, 1 minus 2 squared. I got 5/8, but that might not be right. I think it is. So your equation, it says write the equation, so be sure you go back. 5/8 in the answer. So make sure you go back and put it into the equation. You do not need to multiply that out. All right, anything else from this page?
We do 17.
The height of the wall above the ground is given by this formula. All right, find the maximum height. Well, stop and think about this for a second. What shape is that? Gravel opening down. So isn't the maximum height just gonna be the vertex? And we already talked about that. How do we find the vertex? Negative b over 2a. So it looks like the vertex is gonna happen when t is 2. So we'll plug that in. I think I get 66. Question says, find the maximum height. The maximum height is 66 feet. When does it reach the maximum height? 2 seconds. When does it hit the ground? So think about this equation. How are you gonna figure out when it hits the ground? Well, if you have your calculator, could you grab it? Yeah. But if we don't have a calculator, which we haven't needed one,
2 seconds.
we don't have a calculator, what would we do to find that point right there?
H equals X.
Set it equal to 0. Yep. So solve this equation. Now, I'm not gonna take the time to do that because we don't have that much time to get all this review accomplished. But that's what kind of an equation is that? Quadratic. So you could use, if you're doing this by hand, you could use the quadratic formula to solve that. Now be careful. What was the question again? When does it hit the ground? So whatever you answer, it has to be a positive number, right? You're gonna get 2 answers and one of them's going to be negative. You're gonna have to pick that one out because you want X to be positive or T to be positive. Which one?
20.
Page 20, oh, screw it.
Up below it.
Quadratic equation shifted 10 units right, vertically stretched by a factor of 2 and shifted down 8. Okay, now, Brayden, I'm not gonna do every problem in the review, I don't have time, so we wanna choose wisely, okay? This is a quadratic equation, so we're gonna start out with x squared. So, how do I shift it 10 units to the right? In the parentheses, I'm gonna say x minus 10, right? Now it's shifted 10 units to the right. How do I stretch it? By a factor of 2. No. Plus 2 doesn't stretch
The
it.
2 goes in front of it.
2 goes in front. A multiplier stretches you. Or I should say, a multiplier changes your size. What does a plus and a minus do? That just moves you, right? That just moves you. This changes your size. That moves you. So now I want to go down 8. Minus 8. Here's our equation. All right, let's go to the next page because it's huge. I tried to take out ones. Just some more. A problem that I promised you since the beginning of the year would be on the exam is the box problem, number 20. We've talked about that. I promised you that would be on your exam. Depending on how you do with it, it might be on your semester exam too, or semester 2 exam also. So let's go through number 20 to make sure everybody's got it down. Here's a piece of paper that is 30 by 40. Remember how that works? You cut these corners out. And you fold up the flaps. And we make a box. Right? Okay. Write an equation for the volume of the box. So what will my equation be for the volume of the box? 30 minus 2x. 40 minus 2x. Times that. Length times width times height. So this times this times this. All right, part A done. Sketch the equation. All right, so get your calculator out. This would definitely be a problem you're going to do on your calculator. Now, as you are sketching it, we're going to answer part F. What is the domain of the function? In other words, what is x min and x max? This is question F. What is the domain of the function? But it's going to help me sketch it. 0 to 15. How did we get 0 to 15?
Maybe smaller than 0, maybe bigger than half of the small size.
Exactly. It can't be less than 0. You can't cut negative inches. And the most you could cut is half the smallest dimension, which is 15. So now I'm going to put in my equation. I'm going to go to window and I'm going to set it from 0 to 15 on the x's. And from 0 to, I don't know, I'm going to try 1,000 on the y's. Okay, that wasn't big enough. So I went from 0 to 15, that's non-negotiable. Then I went from 0 to 1,000. That wasn't high enough, so I'm going to go to 5,000. There we go. I'm talking about my y's in my window. My y's. I use 0 and 5,000. You have some flexibility there, but it gave me a nice picture. Something that looks like this. All right, so sketch the equation. Get it. What is the maximum volume of the box? So what do I do? Second, trace maximum. And my maximum is 5.67. I'm writing 657. I'm writing the whole point. 3032.3025. That's what I got for my maximum point. Now, question C specifically says, what is the maximum volume? So that's the Y. So 3032.3025 cubic inches. So this would be the answer to part C. What size, I'm looking at D now, what size would the corners be to have a box with a volume of 2,000? Now, if this is 3,000 right here, then wouldn't 2,000 be down here somewhere? And that is where the volume exactly 2,000?
Yeah.
So I'm gonna go ahead and go back to y equals and put in 2,000 in the graph, and then I do intersect. So second, intersect. Alright, oh, that gives you, this one's just 10.
Yeah, 2. Not yet.
I did the second one first. 2.192. All right, so let's read the question D. What size would they be to have a box with a volume of 2,000? Wouldn't it be either 2.1292 inches or 10 inches? What size would they be to have a box with a volume of at least 2,000? Isn't that right here?
Yes.
So that would be everything
From 2.9.
between and including those, so 2.192. What was the 5.657 number? We didn't use that in our answer. What was that
Max
one?
value of the maximum.
That would be the size to make the corners to get the maximum, which could be a question also. Okay. All right. Um, 13, we've kind of already talked about, but there's a vocabulary word in there I want to make sure doesn't throw you. X. Okay, so it says what are the x-intercepts? Okay, we already talked about that. The x-intercepts are at 1, -4, and 5, right? Everybody's good with that. If we were going to sketch, what is the y-intercept? How do we find the y-intercept again? Plug in 0, so -1, 16, oh good grief, 80? So my y-intercept is up here at 80. Sketch it, that will help us answer that other question. So, okay, now wait, don't let that guy confuse you. You have 4 x's, x to the 4th, which is even, which means this. So I'm gonna start up here. What am I gonna do when I hit -4? Well, the bounds, right? And because I have this point, I'm gonna come all the way up there and pick it up. What happens when I hit 1? Go through. How about when I hit 5? Go through. So there's my sketch. And then this question says, where is the graph tangent to the x-axis? That's what we've been calling a bounce off point tangent.
We're at -3.
Just hits it. So the answer to that question would be where it bounces, which is -4. Also want to look at 23, and then I'll let you pick. I just happen to see this right. We have to, depending on the problem, you may or may not be able to just answer it. You might have to go through the different tests of symmetry, which I'm going to review with you in a second. But does anybody know what that is? What shape that is? What does this thing look like? it's a parabola, opening up, shifted down 4. So without really much effort, I could sketch that, would you agree? And if you can do that without a lot of effort, get it sketched, then you can probably tell what it's symmetric about. Is this thing symmetric about the x-axis? No. That would mean folding my hand and getting the same picture. Well, that's not gonna happen. What about the y-axis?
Yes.
Yeah, this has y-axis symmetry. The origin means points in quadrant 1 are mirrored in 3. That's not true, right? You got a point way up here, you don't have any points down here, so it's not the origin. And then the identity line means if I folded on that crease, I would have the same picture, and I don't. So the only symmetry this one has is y-axis. Again, if you can tell by your basic knowledge of the graph, you're good. But if you can't tell, if the graph is something more convoluted, then we have tests. And I don't know how much time you want to devote to this because, I mean, it's one question and you have a lot of stuff to know. But here they are, just to refresh your memory. Here's my equation. To test for symmetry about the x-axis, I change the sign on y. And then I ask myself, is that the same equation that I started with? No. So that's why I didn't have x-axis. To check the y-axis, you change the sign on x. Is that the same as the equation I started with? Yeah, because won't that negative get squared out? Right? So that's why yes, because of the picture, but the test proves it. Here I switch the variables. Clearly that is not the same equation. And here I make them both negative, x and y both negative, and that will not be the same equation either, because that one will square out, but that one will stay. So those are your actual tests. Take them or leave them. If you can tell from the picture, that's great too. All right, that's it for me. What else do you have? I'm looking at this page. Let's look on this page. What else do you have? Anything else we need to? 19.
Oh, wait, yeah, no.
There's the formula I'm gonna use right there. And Miles, I'm on to you. I'm not gonna give you any more chapters for you to do. That's not what today is for, all right? So here we go. How much, unless someone else asks the question. How much money would you have if you deposited 3,000? Okay, so how much would I have? So I'm looking for A. If I deposit $3,000 in an account paying 0.025, remember percentages must be changed quarterly for 20 years. I'm gonna go ahead and make that 80. What's the beauty of that problem?
You just have to do it.
So you end up with $4,938.47. Right? All right, anybody else have a question from this page? Erica?
It's not from the page, but will we be able to see our test and see, like,
Yes, I'll hand those out on Monday. I still have a couple people to take it yet. So I'll hand those out on Monday. Okay, yeah, one more page to go. There's quite a few on that page too. So here's what's gonna happen. I'm not stopping reviewing. So what I'll do is, if we have no questions, I'll pick a problem and have you come up and do it. Alright, so you better look at this carefully and make sure you can do every problem on here, because you might get picked. There comes some hands. Sydney?
Can you do 22?
22. So I've sketched a couple polynomials already. This one is not factored, so what is the first thing we're gonna have to do? Factor it. Because factoring it is how I get my x-intercepts. So I'll take out an x squared. And that's really all I can do. So where are my x-intercepts? 0 and 2. Now this is a cubic function. Odd. Cube is odd. Odd functions start down here, right? So I'm gonna start down here. What am I gonna do when I get to 0? Bounce back down. What am I gonna get do when I get to 2? Right on through. So there it is.
Can you do number 4?
4, solving compound inequality. Really, really simple to do if you just leave it in one piece. If I said get x by itself, what would you need to do here? Add the 8. We just gotta make sure we add it to all the pieces of the problem. So we'll add the 8 to all the pieces of the problem. And then to get x by itself, we need to divide by 4 all the pieces of the problem. So 3 halves, x, and 7 halves. We always write our answers in interval notation, so we'll have a bracket at 3 halves and a parentheses at 7 halves.
Can you do 12?
12. Who asked that? Hey, tell me what your question is.
I'm just kind of confused what it's asking.
It
Well,
says
it
find the
find the
vertex.
vertex, and
How do we do that?
well, then you'd be plugging in
Yeah,
negative b
wait, we've
over
already
2.
done that, yeah, how do we find the vertex?
Negative b over 2.
Yeah, so that's all we're doing, is finding negative b over 2a. So what's negative b over 2a?
It's negative 6 over 6 is negative 9.
Alright, and then we plug in negative 1. And we're going to get negative 4, so there's my vertex.
And then, what does it mean when it says, how does this compare to?
So the regular quadratic has a vertex at where? 0, 0. So what has happened? This guy has been shifted left 1 and down 4. And there's another change that's been made to it. What's the other change that's been made? It is 3 times as tall. It has a leading coefficient of 3. Look at your equation. Right? So it's been stretched this way by a factor of 3. Yep, they're exactly the same parabola. Only the problem has been shifted and stretched. All right, back side. All right, what do we got on the back? Some of it's repeat, but some of it we haven't talked about yet. Number 7, number 7, find the interval where it's decreasing. that means.
-1 to
-1 to 1, very good. As you go left to right, where is the curve going down? Well, it starts going down when x is -1, and it stops going down when x is 1. So that would be it, -1 to 1. Nice work. Yeah.
24.
24, function is defined parametrically by these two equations. Find the coordinate on the point if t is 0. All right, now call on. Yeah, so the point, that question's easy. The point would be -1, 3. Write the Cartesian equation, and that means, see, this has t's in it. You wanna write an equation that's x's and y's. Regular equation, in other words. By eliminating the parameter, all right? That means you gotta get rid of the t's. So what's an idea you have? What? You can do that. That's gonna be tough because I'm squared. So it's doable, definitely doable. I personally would probably solve this one and then plug that in right there. So I'll have x equals y minus 3 squared minus 1, which is, again, that's a FOIL. So y squared minus 6y plus 9 minus 1. So x equals y squared minus 6y plus 8.
Yeah.
And then it says graphic. So you have a couple of options. One option you have is, you know how you said if t is 0, x is -1, and y is 3. So one point we know for sure is going to be on the graph is -1, 3. So we could plot some more. We could say, okay, well, what happens if t is 1? Well, then my x would be 0, and my y would be 4. So 0. Do you see what I'm doing? So one option you have is to just make a big table of values by picking t's, and you can pick whatever t's you want. So -1 would be 0, 2, and so on. You could also, if you are a little more intuitive, what does that look like right there? Doesn't that look like the equation of a parabola? Except the letters are wrong. So the normal parabola would have a y here and an x there, and it would open up. Well, when you switch it and put the x here and the y here, it's still a parabola, but now it opens to the right. And the vertex is exactly where you would expect it. The vertex is at -1, +3. So -1, +3 opens to the right. So there's a picture. So if you can make that connection, then you can graph it that way. If you can't make the connection, then plot some points. Wasn't I on my way to getting that with my points? So you could do it either way.
There'd be a negative coefficient going up to the left.
Yep. Yep. Negative out here. All right, what else? Yep. Each one, 30. Okay, this is like the one we did a little bit ago. Same kind of problem. How high is the rock after 1.1 seconds? What would I do? Plug in 1.1. Okay, Cindy, plug in 1.1. That's it. Whatever you get, that's what you get. What is the maximum height? Again, isn't this like this? So the last one, yeah, so I need the vertex. The last one I did by hand. These numbers aren't as nice and it's stars, so I'm gonna do this one on my calculator. So I'm gonna go ahead and graph this equation. I'm gonna go back to a standard window. What's gonna happen? I can't use the window I just used because that was wild. So negative 16 t squared. T is like x plus 19x plus 32. I'm gonna have to make a couple of adjustments to get a better picture. And remember, you're allowed to do that. So I'm using negative 5 to 5 for x and negative 10 to 100. And I got a great picture. Got a beautiful picture of a parabola opening down. I want to know what's its maximum height, so I will find the maximum of that. And it looks like my maximum is a point 0.594, 37.641. So what is the maximum height? 37.641 feet. When does it reach its maximum height? 0.594 seconds. When does it hit the ground? I'm looking for that point right there. So I can second calc 0. It's gonna hit the ground at about 2.128 seconds. That's where my y is 0. So if I were doing it by hand, which you would never have to do this by hand because the arithmetic is so bad, but you would set this equal to 0.
4C.
4C says find the y-intercept. Okay, Erica, you're letting yourself get freaked out by the way the equation looks. How do you find the y-intercept?
Plug in 0 for x.
Plug in 0 for x. It doesn't matter what the equation looks like. We plug in 0. What is 3 to the 0? 1.
Over 8.
12 over 1 plus 8. So 12 over 9 So your y-intercept is 4/3. It doesn't matter what your equation looks like, you're going to plug in 0 for x to find the y-intercept. So for D, if we plug in 0 for x, what does that tell us about t? I'm talking about 4D. So t has to be 3. And if t is 3, what is my y value? 11. So what's your y-intercept? 11. Number 29. How about all that? Domain, asymptotes, holes, intercepts, all that. Gotta factor it first. Looking at 29. So let's see, x plus 5 minus 3. X plus 5 plus 4. Okay, I'm factored. Now what? We can cancel, which means we're going to have a hole where? I'm gonna have a hole where x is -5. And if x is -5, then I'm going to get 8/3. Is that right? I plug in -5 here. So I'm graphing here. So -5, 8/3. There's my hole. Alright, what else do I need? Asymptotes. Okay, what are my asymptotes? Vertical, horizontal. You know what that matters? Erica?
Is it -2?
My vertical is x equals -2. Yep. Because what happens if you let x be -2? You're right, you can't do it. What are my horizontal asymptotes? Y equals 1. What about my intercepts? For like the 12th time today, what's the y-intercept? -3/2. And what's my x-intercept? 3. Could you sketch it from here if you had to? And the only part of that question I didn't answer is the domain. What's the domain? Negative infinity, -5. -2. And then -2 to infinity. Remember, your domain includes everything except what it can't. In the original problem, x x could not be -5, x cannot be 2. -2, -5 or -2. So we have everything except what's on the number line, it's like this. Everything except those numbers. Alright, what else? On this page, number 2, find the symmetry. So you can graph it, you absolutely can, if you're comfortable doing that. And then eyeball it. I'm gonna go ahead and do my test of symmetry. So x-axis, y-axis. So I'm gonna make these changes and see if I get a match. So this one is easy, I change the sign on y. Do I get a match? Change the sign on x. I don't think that one's gonna work either, because isn't it gonna make that positive? Here I switched them. Very clearly, that isn't the same equation. And here I make them both, this one might work. I make them both negative.
Is the last.
I think that's gonna work. Let me double check. There's something wrong. So I'm gonna have negative y. This is gonna be negative x cubed. And that's gonna be positive x. But when I divide out the negative, I get my original. So this one has symmetry about the origin. If you wanted to graph that, you could probably tell from that graph. Sometimes your eyeballing is a little iffy. This will never fail. This works every time. I think you can tell that. All right, what else? Open it back up to the whole packet. Anything we skipped over? That we shouldn't have. Number 20, let's see, on the back of the first page, number 21 is a reminder that you need to remember your BFFs. Number 21 deals specifically with the exponential, but that could be any of the functions. If you remember what your curve looks like, so the exponential, remember, is this one? If you can remember that, you can answer all of those questions. What is the domain of that curve? All of those, negative infinity to infinity. What is the range of that curve? 0 to infinity greater than 0? Is that curve continuous? Yeah. Does that curve have any asymptotes? Y equals 0. Is it increasing or decreasing? Increasing left to right? Now be careful with that question, because if you're analyzing the quadratic, it's decreasing and then increasing, right? So some of them change. That one doesn't. That one's strictly increasing. Would you consider that bounded? Bounded below, not bounded above, so therefore not bounded in general, but I would say bounded below. I would say that. And what is its end behavior? Remember the notation you use for end behavior. The limit as x approaches negative infinity, and the limit as x approaches positive infinity. Alright? So what happens negative infinity? This is left. What happens as we go left?
Approach to zero.
We get closer to zero. I always put a little plus here because we do that in calculus class. That tells me I'm coming in from the top of it. And then what happens that way? Positive infinity. I'll just go bigger and bigger and bigger. So when a question refers to end behavior, this is your notation. That's your notation. All right, number, on that same page, one right next to it, number 19, I guess that's a 19. This is your regression on your calculator. So let's take a list of our ordered pairs. If negative 1 minute late, he gets 1 detention. If he's 3 minutes late, he gets 4 detentions. 4 minutes late, he gets 11 detentions. Write a quadratic equation using your regression capability on your calculator. Alright, we can do that. So we go to start edit. Then I go to stack calc and choose quadratic because that's what it told me. And my equation turned out to be that. Alright, so now I'm ready to answer the next question. How many detentions will Nate get if he is 5 minutes late? What would I do? Plug 5 in that equation right there. It's going to be some decimal probably, so just round it off to the nearest whole number. But we're going to plug 5 in right there, and that will tell us what this number is right here. 22. And then, what is the minimum number of detentions that he can receive? Well, I was trying to be clever in my problem, it's really kind of stupid, because obviously the minimum number of detentions you can get is 0. But what I'm trying to do mathematically is have you recognize, what do I need to do here? How do I find the minimum of this equation? Actually, I'm shooting for mathematical, not realistic practical terms. Wouldn't the minimum be the vertex of this? Right? So I'm either going to do negative b over 2a, or I'm going to graph that on my calculator and find the minimum. The vertex is the minimum. Alright, it's not going to make sense because it's going to be some negative number, but that's what I was trying to do. Alright. That's a lot of stuff. We have one more review session